Rochayne and I am a chemist here at High School Inc.
Hi, my name is Emely and I'm a chemist here at High School Inc.
Hello, my name is DeQuan and I'm a chemist here at High School Inc.
In this series, we will be covering how to calculate molar mass of a compound, calculate moles from grams and vice versa, calculate percent composition in empirical formulas, write balanced equations, using balanced equations to establish ratios between reactants and products, the mass of reactants and theoretical product yield using a balanced chemical equation. Compare theoretical and actual quantity of products to calculate percent yield. What is molar mass?
Molar mass, a number equal to the sum of the atomic masses of the atoms in a molecule.
I don't understand.
Okay, Erica, let's look at H2O, also known as water, y agua, or dinitrogen monoxide. Here we have the periodic table. For this exercise, we will be looking at hydrogen and oxygen. Now let's look at oxygen, which has an atomic mass of 16. Now you add the masses. So here you have it. The molar mass for H2O is 18 grams per mole.
What is a mole?
My grandma has them on her lawn all the time. Can't deal with that bullshit.
.02 times 10 to the 23rd power representative particles of that substance and is the SI unit for measuring the amount of a substance.
In this exercise, we'll be converting from moles to mass and vice versa. We'll be using Al2O3, or also commonly known as aluminum oxide. The first step is to determine the mass of 1 mole of aluminum oxide. For that, we'll need to find the atomic mass of both atoms present. Aluminum, which has a mass of 26.9, or rounded to 27. And oxygen, which has an atomic mass of 15.9, or rounded to 16. In order to find 1 mole of aluminum, we have to look at how many aluminums are present. We know that in this compound there are 2 aluminums present, so we'll set up our little equation. It would be 2 moles of aluminum. And remember, it's 2 moles because there are 2 aluminums present. You multiply that by the atomic mass, and you divide that by 1 mole. Two multiplied by 27 gives you 54. And since there's the 1 at the bottom, the answer stays the same. So that'll give you 54 grams of aluminum. Notice how your units cancel out. You have mole here and another mole here, so those two cancel out. You also have an aluminum at the top and another at the bottom. Now you're left with just grams of aluminum, so your answer will be grams of aluminum. Now let's look at oxygen. Just like before, it all depends on how many are present. In this equation, there are 3 oxygens present. So our new equation will be 3 moles of oxygen times the atomic mass of oxygen, which is 16. And that would be over 1 mole, since you are looking for 1 mole. So, like before, you just simply multiply 3 by 16 and disregard this one because your answer will still be the same. So 3 times 16 gives you 48 grams of oxygen. The next step is to identify the conversion factor relating moles of aluminum oxide to grams of aluminum oxide. So to do that, here's what you do. 1 mole of Al2O3 equals 54 grams of aluminum plus 48 grams of oxygen. Altogether, the 54 that you got from the aluminum plus the 48 that you got from the oxygen together gives you 102 grams of aluminum oxide. Problems as such always come with a given. In this problem, our given was 9.45 moles of aluminum oxide. What you simply do is take that 9.45 and multiply it by the sum of the 54 and the 48. Or the 102 that you found prior to this. Now, after you do your math, you should get 964 grams of aluminum oxide. For your solution, your unit would be grams of aluminum oxide because, remember, units must cancel out. You had moles at the top of the axes and there was another mole at the bottom, so those two cancel out. Now, the only thing you're left with is grams of aluminum oxide. So after you do your math, whatever unit you're left with is the unit that your solution will be in. So, of course, it would be aluminum oxide. In the previous exercise, we converted from moles to mass, but in this exercise, we'll be converting from mass to moles. The question is, how many moles of iron 3 oxide are contained in 92.2 grams of pure Fe2O3? I must explain a piece of information in greater detail before I continue on with the problem, because if you make a mistake between these two, it can result in a very awkward or, well, incorrect solution to your problem. In the beginning, the question said how many moles of iron 3 oxide are contained in 92 grams of pure Fe2O3. Iron is a transition metal, meaning that whenever you have them in a question, they will always be a Roman numeral behind it telling you the charge of that transition metal. And it told you that in the beginning that iron's charge was 3. But then here you have oxygen, which has an oxidation number of 2. The reason why you switch these is because it's an ionic compound. Whenever you have an ionic compound, you always crisscross the charges. So that 3 that came with the iron in the beginning of the question is now swapped with the 2 that came with the oxygen. Now let's dive into the problem. First thing you do is list your givens. From the question, we know that our given is 92.2 grams of iron oxide.
What is an empirical formula? An empirical formula is a formula with a lowest whole number ratio of elements in a compound. Our next lesson is determining the empirical formula of a compound. A compound is analyzed and found to contain 25.9% of nitrogen and 74.1% of oxygen. What is the empirical formula of the compound? Our knowns are the percent by mass of nitrogen, which is 25.9% nitrogen, and percent by mass of oxygen, which is 74.1% oxygen. Our unknown is the empirical formula for the compound nitrogen, oxygen. Our first step is to convert the percent by mass of each element to moles. First, we'll start with the percent by mass of nitrogen. Now, in order to calculate the percent by mass of nitrogen, you use the percent by mass of nitrogen, 25.9 grams of nitrogen, and multiply it by the amount, by 1 mole of nitrogen and the mass for 1 mole of nitrogen, which is 14 grams of nitrogen. You cancel out any similar symbols, and after doing the math, you end up getting a 1.85 moles of nitrogen. And the same is then done for the percent by mass of oxygen. You multiply it by 1 mole of oxygen and divide the 1 mole of oxygen divided by the mass for the 1 mole of oxygen, which is 16 grams of oxygen. Cancel out any similar symbols. And after doing the math, you end up getting 4.63 moles of oxygen. The mole ratio of nitrogen to oxygen is now nitrogen 1.85 and oxygen 4.63. The next step is to divide each molar quantity by the smaller number of moles to get 1 mole for the element with the smaller number of moles. So, like I just said, smaller number of moles, and the smallest number of moles is the amount of moles for nitrogen. So, like I said, you divide that by the smallest number of moles in order to get 1 mole of nitrogen. And you do the same and divide the amount of moles for oxygen by the smallest number of moles in order to get the number of moles for oxygen. The mole ratio for nitrogen to oxygen is now nitrogen 1 and oxygen 2.5. Oh, sorry. The moles for oxygen is 2.50 moles for oxygen. After that, you then multiply each part of the ratio by the smallest whole number that will convert both scripts into whole numbers. So, multiply 1 mole of nitrogen by 2 in order to get 2 moles of nitrogen, and multiply 2.5 moles of oxygen, 5 moles of oxygen. We use 2 as the smallest whole number. In order to get the empirical formula, which is now nitrogen 2 and oxygen 5. Percent composition is the percent by mass of each element in a compound. Our first step is determining the percent by mass of magnesium in the compound. In order to determine the mass of magnesium in a compound, you have to divide the mass of magnesium by the mass of the compound and then multiply it by 100. And then you substitute the actual numbers. And cancel out any similar symbols. In order to get 60.3% of magnesium in the compound. The next step is determining the percent by mass of oxygen in the compound. Determining the percent by mass of oxygen in a compound is similar to how we just determined the percent by mass of magnesium in the compound up here. In order to get the same result, you have to repeat what you did, except substituting the numbers from oxygen. And you will end up getting 39.7% of oxygen in the compound. In this lesson, we will be calculating the percent composition given the mass of the elements. When a 13.60 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.40 grams of oxygen is obtained. What is the percent composition of this compound? These are our knowns and unknowns. The mass of the compound, which is 13.60 grams, the mass of oxygen, which is 5.40 grams of oxygen, and the mass of magnesium. To get the mass of magnesium, you subtract the number of grams for oxygen from the mass of the compound in order to get 8.20 grams of magnesium. Our unknowns are percent by mass of magnesium and percent by mass of oxygen.
In order to have a balanced equation, you need to have the same amount of atoms and the reactants as well as the product side. In this lesson, we'll be balancing equations. Here we have aluminum plus dioxide yield aluminum trioxide.
What is a ratio?
Ratio is the quantitative relation between two amounts showing the number of times one value contains or is contained within the other.
Previous exercises, my colleague Emily had beautifully balanced this equation for you. Now, what I'll be doing is I'll be using the same balanced equation to establish a ratio between reactants and products. Now, let's take a look at the equation. Let's say that the question is, what is the molar ratio between aluminum and oxygen? Now let's look at it. There, on the reactant side, we have 4 moles of aluminum and 3 moles of O2. So if we were to establish a ratio between those, we would say, now on the reactant side, what they're saying is they're saying that there is 4 moles of Al per 3 moles of O2. It also doesn't matter what order it's in. You could have also said that there are 3 moles of O2 for every 4 moles of aluminum. Both are correct.
The theoretical yield is the amount of a product that could form during a reaction calculated from a balanced chemical equation.
In this lesson, we'll be calculating the theoretical yield of a reaction. What is the theoretical yield of aluminum if 40.5 grams aluminum trioxide is heated? In this lesson, we'll be using this balanced equation. First, we start with the mass of the reactant and convert the moles of the reactant. So we put 40.5 grams aluminum trioxide Now we have to find the mass of aluminum trioxide, which 101.96 grams of aluminum trioxide. Next, we convert the moles of the product using the mole ratio. So we times this by 1 mole of aluminum over 1 mole of aluminum trioxide. And we finish by converting from moles to mass of the product. So we're gonna, we find the mass of aluminum, which is 24, but it's times 2, so it's 50. I'm sorry, the mass of aluminum is 26.982. 27 times 2 is 53.964 grams of aluminum over 1 mole of aluminum. Now we have to cancel out our units. So we have grams of aluminum trioxide and grams of aluminum trioxide here. We also have aluminum trioxide and aluminum trioxide here, so it's canceled out. Moles.